Let's try an application problem with quadratics. So this question says a soccer ball is kicked into the air and its height h in meters is approximated by the equation, here it is, where t is in the time where t is the time in seconds since the ball was kicked. So this makes sense that this is a quadratic. We have a degree 2 polynomial because if we were to kick a soccer ball in the air, wouldn't it make the shape of a parabola, an upside down parabola? So now we've got some questions about this equation. So we've got to just decode these questions and figure out what is it actually asking and how can we figure it out from the equation. So if we were to draw a quick sketch, before I even take a look, before I even see what the questions are asking, I know that generally a soccer ball would make this shape when it was kicked. Maybe it started on the ground, maybe it didn't. We're going to have to figure that out. And on our x-axis, we're measuring time, and on our y-axis we're measuring height. So we have time here and we've got height here. So the first question says, from what height is the ball kicked? From what height is the ball kicked? So immediately I know that we're looking for height. We don't know what height is. And if we're looking for height, we must be given time somehow. Well, where is the ball kicked from? What height is the ball kicked? Well, here it's on the ground. Here it was where it was originally kicked. So this is the point that we're looking for. This guy right here. So at this point, what do we know about this point? Well, we have no idea what the height is, but what's the time here? Isn't the time 0? This is the start of the story. This is when the timer is about to go off. How high is that ball? So at this point here, we know that time is equal to 0. And that's what's going to help us to figure out this solution. So we're looking for the height when time is equal to 0. So that's easy. We're just going to plug in. We're looking for our height. Oops. And we're going to plug in t equals 0. So -2, 0 squared plus 8, 0 plus 0.5. And we know that this is just going to equal 0.5. So that means that this starting height right here must be 0.5. If we want to, we can check our answer in Desmos. So here's the parabola that we were given, graphed in Desmos. So we're just going to check our answers here. So notice Desmos doesn't like when we use h and t, so I just switched them to x and y. And here is the parabola, or here's the graph of the soccer ball that's been kicked. Okay, and we were looking for this point right here. So if it went through the origin, we would know that the height of the ball was on the ground when it was kicked, and if we plugged in 0, we would have got a height of 0. But we want to just triple check what that height is right there. So if we were to click this here, we're going to see the point 0, 0.5. So we know that the height is 0.5 when our time is equal to 0. Now let's figure out the next question. After how many seconds will the ball hit the ground? One more time. After how many seconds will the ball hit the ground? After how many seconds means, are we looking for the height? Are we looking for y? Or are we looking for time, x? After how many seconds? Well, that's clearly time. So in this question, we're searching for t, which means we must be given h this time. So the question is, according to our graph here, whether we have our sketch, which is underneath this Desmos one, or this Desmos graph, where does it hit the ground? Well, here's where it starts, and then it comes up, 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 and hits the ground right here. So the question is, what do we know about this point right here? Well, we don't know the time. Well, we do because we have Desmos. Let's switch this over. Okay, so now we hit Desmos, so we don't know the answer. We'll check it. We'll use Desmos to check our answer. So we know we're looking for this point here. We're looking for when it hit the ground because that's going to tell us how long it took until it hit the ground. So at this point here, we don't know the time, but we do know the height. If something is on the ground, what's its height? Well, it has to be 0, and that's what it shows on our graph as well. So in this question, we don't know the time, but we do know the height. The height is 0. So now the hardest part of the question is done, which is interpreting what is the question actually asking for and what is it giving us. It's asking for the time when the height is equal to 0. That's going to tell us how long it's been in the air. So let's just plug it in. Instead of h, we're going to put in 0. So we have 0 is equal to negative 2t squared plus 8t plus 0.5. Now the question is, this is a quadratic. We've got more than one term with t in it, and they're not like terms. One of them squared, one of them is degree 1. How do you solve this? Well, we've got two options. We could either factor it or use the quadratic formula. So if we were to factor it, first of all, we're dealing with a decimal here. And that doesn't mean it can't be factored, because if we really wanted to, we could multiply this entire equation by 2 and the left side multiply by 2. We wouldn't have a factor. We wouldn't have a decimal anymore. But it might be faster just to use the quadratic formula. So we can factor or use the quadratic formula. I see a decimal, not impossible to factor if we were to multiply by a whole number. But let's just put in the quadratic formula. So here's our a value, here's our b value, and here's our c value. Another check is make sure that one side is equal to 0, because that's the only time the quadratic formula is going to work. And plug this into the quadratic formula and come back to the video once you're done. Alright, so after we've used the quadratic formula, we're going to get two solutions. And we have negative 0.06 and 4.06. So that means that these are the two values of x that are going to satisfy this equation. Now if you notice, in this equation we don't actually have x, we have t. So if we've written x, let's just go change this and we're going to put t instead. So this is actually a t, t, and t. So these are what t equals. So these are the two values of t that satisfy this equation, which means the height is 0 when t is equal to negative 0.06 seconds and 4.06 seconds. So what must this one be? Well, this one can't be negative 0.6. This must be 4.06. But why are we getting 2? I only see one x-intercept here. Let's go back to our Desmos graph and see what's happening. If we take a look at it, this parabola opens down and it clearly has two x-intercepts. Let's see what these x-intercepts are. So if I were to click on this guy right here, we get 4.062, and that's what we said one of the x-intercepts were. Where's this negative one coming from? Well, if we click this other guy right over here, oops. There we go. So if we click this other guy, we have another x-intercept of negative 0.62. Now, x represents time. Can time ever be negative? No. This number doesn't make sense in the context of our problem, but this one does. So that means the ball started its life or its journey at 0, at time equals 0, went up and around and hit the ground at 4.062 seconds. So this is the x-intercept that makes sense for this problem, and that's going to help us. So therefore, we can say that the soccer ball was in the air for a total of 4.06 seconds. Let's take a look at the next part. It says, what's the maximum height of the ball? Well, we know the word maximum. That must mean the vertex. That's going to be the highest point. So we're going to be looking for this guy right here. So how the heck do we find the vertex? Well, we know that we can just find the midpoint of the two zeros and then plug that midpoint in to find our y value. So make sure you're not finding the middle between 0 and 4.062, because those aren't the two x-intercepts. Even though this x-intercept wasn't useful to us in the previous question, that doesn't mean it's not an x-intercept. So we've got to use our first x-intercept that we found, negative 0.6, and add together with our other x-intercept, 4.06. Divide those by 2, find the axis of symmetry, and plug that in. So we'll take our first x-intercept, 4.06, add our second x-intercept, negative 0.06, divided by 2, and we're going to get 2, which is the x value of our vertex. So now go ahead and find the y value and come back to the video. So if you plugged in our x value, we should get a y value of 8.5. And that makes sense because 8.5 is greater than 0. If we've got a negative number, we've got something wrong because then our vertex would be down here and we'd have a minimum. So this looks like it would be a maximum. We'll check it in Desmos, but let's first do our conclusion. So now if I click on this vertex, what number do I get? We get 2, which is the x value of a vertex that we said, and 8.5. Done.